Good day, sir. Here is my created presentation about an application of Geographic Information System or GIS in the field of biology, featuring the paper of Jumawan and Macandog entitled GIS Weighted Suitability Analysis as Decision Support Tool for Mangrove Rehabilitation in Oriental Mindoro, Philippines. Mangroves of the Philippines. Primarily, the mangrove cover in the country experienced extensive degradation due to it being converted to aquaculture ponds. The Philippine mangrove cover was almost 500,000 hectares in 1918, but it was reduced to nearly 130,000 hectares in the year 2000. Much of the decline occurred during the 1960s to 1970s when the government policies preferred aquaculture expansion. Rapid urbanization, industrial complexes, and human settlements were considered other factors which further exhausted the mangroves. These occurrences have significantly reduced the mangroves in the country, which amounted to 70% total loss from the original forest cover. In the previous decade, the Philippine government started programs to improve the degrading mangrove conditions. Reports indicated that mangrove cover in the country somewhat recovered from the continuous decline. However, the rehabilitation activity also had some negative consequences in that the replanting primarily of monospecific culture had high mortality. Moreover, planted seedlings in unsuitable lower intertidal sites were questioned about replacing seagrass beds, and replanted seedlings proved to be costly in the long run. Suitable areas must then be determined to effectively reduce the cost in the implementation of mangrove rehabilitation actions. To provide implications in suggesting suitable areas, ecological components of mangrove habitats can be recommended. Fundamental research approaches generated vegetation structure as part of data inventory for rehabilitation, and this can be utilized as vector and raster data inputs which can be manipulated using geospatial techniques. With that mentioned, geospatial analysis has been deemed a valuable tool for mangrove rehabilitation and management, and the Geographic Information System or GIS as a new and emerging platform has been suggested as a reliable method in generating suitable areas of mangrove habitats. Generally, the spatial data used in the study involve the vector and raster data. Figure 1 shows the table presented in the paper that displayed the spatial data utilized in the study. As can be observed, the data types include polygon, line, and raster. As for the employed non-spatial data, this would concern the provided description and other information that were associated with the respective thematic maps used in the study. Figure 2 displays such data. Now, taking for instance the soil types, the provided description include sandy loam, beach sand, clay loam, silt loam, clay, and loam. The data analysis technique employed for the identification of mangrove suitable sites for rehabilitation was weighted suitability analysis. It is further described as a GIS technique that ranks variables and weighs them based on their importance. In this, the utilized vector data were rasterized, reclassified, and measured for suitability on a similar scale, and each of the combined raster layers was assigned a relative importance value. More specifically, the individual thematic map was reclassified into units of suitability and multiplied to a corresponding weight. The relative importance of each thematic map was designated with influence as follows: A. Mangrove areas 30%, B. Land cover 20%, C. Rivers 15%, D. Roads 15%, E. Soil types 10%, and F. Slope 10%. The weight influence is based on the level of significance of each data input for determining suitable mangrove areas. The thematic layers with their corresponding designated influence were then added to derive a suitability value in every site of the map boundary. Furthermore, the shown formula was used in the analysis. In the formula, S is the suitability index for each pixel and map. Wi is the weight of criterion I, and Xi is the criteria score of class I. The formula exhibited was applied to the actual thematic layers being integrated as a platform for weighted overlay. The final score for suitability index was converted into suitability classes, namely low suitability, mid suitability, and high suitability. The final output was displayed as a predicted mangrove suitability map. In addition, the area of mangrove suitability classes was extracted using a zonal geometry tool. The zonal geometry tool is a feature in ArcMap Spatial Analysis extension which could extract raster information and quantify the value of the raster cells. The process flow of the data manipulation or analysis utilized in the study to identify mangrove rehabilitation sites in Oriental Mindoro, Philippines can be seen in Figure 3. The displayed figure shows the reclassified data inputs utilized in the prediction of mangrove suitability in Oriental Mindoro, Philippines. This include land cover for A, soil types B, slope C, mangrove cover D, rivers E, and roads F. Some of the key findings from the featured study, which depicts the interaction with an imperative concept in the field of biology and GIS, would involve the following. Through the aid of a weighted suitability analysis, there was a generation of a suitability map that predicted potential rehabilitation areas in Oriental Mindoro, Philippines, and this can be seen in Figure 5. Moreover, it was discovered that the predicted land area suitable for mangroves is about 75,433.20 square kilometer in Oriental Mindoro, Philippines. Now, among the three suitability categories, the mid-suitability areas gave the highest predicted area for mangroves with 41,326.22 square kilometer. This was followed by the low suitability areas with 32,018.93 square kilometer and high suitability areas with 2,088.05 square kilometer. There were only 3 municipalities with high suitability areas, and these were Naujan, Calapan City, and Baco. Additionally, suitable areas were detected in 10 out of 15 municipalities of Oriental Mindoro. Furthermore, an advantage of the study was its functionality in the planning and management of mangrove resources in different municipalities. It may provide several options for environmental managers in planning across various levels. It can be integrated or utilized as a support tool for a better understanding of mangroves in the entire province. In this manner, managers can carry out accurate decisions and execute significant actions. This provides a framework as a support tool in finding alternatives in future developments. Now, the figure shown is the predicted mangrove suitability map showing the low, mid, and high suitability areas in the municipalities of Baco for A, Bansud for B, Bongabong for C, Calapan City for D, Gloria for E, Mansalay F, Naujan G, Pola H, and Puerto Galera I. A future step possible that would still incorporate the application of GIS in suitability studies, which was actually mentioned in the paper, is the use of a multi-criteria method in evaluating suitability studies based on geographic information system applications because of the inclusion of multiple factors. Such a suitability procedure certifies the weight distribution of score classes using the analytical hierarchy process or AHP and resolves multi-criteria decision-making or MCDM problems. Here is the reference I used. That would be all. Thank you for listening.